In this video, I'll be providing you some fundamentals and I'll be guiding you on how to use Microsoft Excel on one sample hypothesis test. Now, what is a one sample hypothesis test? Now, one sample hypothesis test is used when involving only one population. So you can look into this diagram here, where we have the entire population, okay, one population, and we are going to pick up a sample. Now, for example, for the population of patients who have recovered from COVID-19, so this is the population of patients who have recovered from COVID-19, we draw a sample to test the risk of getting reinfected. Okay, so we are just referring to one specific population and picking up a sample from that population. So we have our sample. What to do next? Okay, I'm sure that if you have watched my past video, once we already have an idea, we have already written our hypothesis based on our sample. Okay, so what we are going to do now, we need to decide what are the type of tests to run in order for us to make a decision on our hypothesis. So there are two types of tests, statistics. One sample test for mean, sigma known, and one sample test for mean, sigma unknown. What is sigma here? Sigma is the population standard deviation. So let's look into the first test first. One sample test for mean, sigma known. So we will use the Z test here. So X here refers to the sample mean minus the hypothesized mean divided by the population standard deviation divided by the square root of the sample size. For one sample test for mean, sigma unknown, you do not know the population standard deviation, we will use a t-test. T equals to sample mean minus the hypothesized mean divided by the sample standard deviation divided by the square root of the sample size. So these are the two tests we have. So you need to decide, pick up which test based on the sigma, whether the population standard deviation is known or unknown. And in most of the situations, the population standard deviation is commonly unknown. So most of the time you will see that investigators will be picking up the t-test. So now you have already decided on the t-test, okay, or probably z-test, okay, based on the availability of the population standard deviation. So once we have the test statistics, we need to make a decision. Remember, you want to whether reject or do not reject your null hypothesis. So after conducting the test, you can't immediately make a decision. What you need to do is, you need to use a critical value approach or the p-value approach to make a decision. So what we have to do is that, remember, you have your z-test and your t-test. You need to compare the test with either the critical value or with the p-value in order for you to decide. So we have to compare the test statistics. Remember, we have discussed two tests, sigma known and sigma unknown. We have to compare that test with the critical value or the p-value. Or you can even do both the tests in order for you to decide whether you need to reject or you do not reject the null hypothesis. Let me shed some light on critical value. So remember, when we say the sigma is known, we are going to use the Z statistics. Okay, the Z test statistics. So for the critical value, we will use the standard normal distribution. Okay, and we find the Z value. When the standard deviation of the population is unknown, we are going to use the t-test, okay, statistics. So we will use the t-distribution. So we have the standard normal distribution table and we have the t-distribution table, which we used to, okay, which you usually have behind your statistics textbook, which you want to find the critical value for Z using the standard normal distribution, or you want to find the critical t value from the t distribution. So we can actually find the value, okay, using the table. But what we are going to do in this video is we want to see how do we determine the critical value using Microsoft Excel. Yeah. So when we talk about critical value, you need to decide whether it's a two-tailed test or whether it's one-tailed test. How will you know whether it's a two-tailed test or one-tailed test? Remember, if your hypothesis can have an equal sign, okay, or it will have a sign which is greater than or equal to, or lesser than or equal to. So let's say if your null hypothesis is having an equal sign, it means that you need to use a two-tailed test. Okay. So this is how, okay, your distribution will look like. You will have the rejection region, okay, both on the upper and the lower, and you have the non-rejection region. So what will happen? Okay, once you collect, okay, your test statistics, if it falls in the rejection region, it means that you will have to now reject your null hypothesis. And if the t-test value falls, okay, within the non-rejection region, what you will do, you will fail to, okay, reject the null hypothesis. Yeah. So we will go into these things in detail. But firstly, you need to understand very clearly whether now you need to select a two-tailed test or a one-tailed test. So you will, for one-tailed test, we have lower one-tail. So when will you select a lower one-tailed test? Lower one-tailed test will be selected when your null hypothesis, okay, is greater than or equal, and your alternative hypothesis H1 is smaller than. Can you see smaller than? Try to, okay, pay focus on this symbol here. When it's smaller than, then we will use the lower one-tailed test. So technically, it's on the negative side here. Okay. So what happens? Okay, once you find, okay, the critical value. So if the test statistics is lesser than the critical value, we reject the null hypothesis. So it means that if, okay, the test statistics that you have calculated, if it falls in this region, then automatically we will reject the null hypothesis. And if the value of the test statistics fall here, which is the non-rejection region, then we do not reject the null. Yeah. Then for one tail, there is also upper tail. When do we use the upper one tail test? When your null hypothesis is lesser than or equal to, and your alternate is greater than. You see, greater than is on the positive side here. Okay. If the test statistics is greater than the CV here critical value, we reject the null hypothesis. So the same thing, if your test statistics that you have calculated falls, okay, in the rejection region, then you will reject the null. And if it falls here, which is the non-rejection region, you will not, or we will say you fail to reject your null. Yeah, so you need to bear in mind whether you need to use two-tailed test. Remember, the sign will be equal. Lower one-tailed test, when over here, the sign in your alternate here is less than. Upper one-tailed test, you can see it's on the right-hand side here, okay, when the symbol for your alternate is greater than. Okay, so it will be easier for you to determine, okay, your critical value. Let's try an example, okay. I'm sure I've given some fundamentals. Well, it will make sense, okay, as we do an example over here. Let's look into this example. A premier parcel delivery service in Malaysia that delivers legal documents to overseas businesses claim that it delivers within 8 days. The parcel company CEO received complaints with regard to the delivery period. So he collected a sample of delivery period from 50 businesses to investigate the issue, right? So, what does this premier parcel delivery service in Malaysia claim? They said that their hypothesized mean is lesser than or equal to 8 days. Okay, but people have actually complained. Yeah, they are not adhering to what they have actually claimed. Okay, so this is what we want to This is what the CEO wants to test now. Okay, that the hypothesized mean is greater than 8 days. Yeah. So we know from here, okay, if you look into the example, we have collected a sample here. We do not know the population standard deviation. So we are going to use a t-test. Yeah, I repeat again because sigma unknown. And we need to now find, okay, in order for us to calculate the t statistics, we need to know what is the mean and we need to know the sample standard deviation. Yeah. So what we are going to do, remember, in order to make a decision, we can either use the critical value approach or the p-value approach. So let's look into the critical value approach first. Yeah, so we already known, okay, from the hypothesis, okay, over here, the alternate hypothesis shows greater than 8 days. So we are very sure we are going to use this one here, okay, which is the upper tail. Yeah. So this will be, okay, the rejection region. But what we have to do is we need to determine what is the critical value here. Yeah. So to find the critical value, we have already fixed the significance level. Yeah, the significant level, yeah, the alpha equals to 0.05. So what we can do is that we can find the critical value. Okay, how do we find the critical value? We can use an Excel formula. Yeah, so this is the Excel formula, T dot I and V, okay, bracket 1 minus alpha, okay, comma, n minus 1. So the n minus 1 here is the degree of freedom. Yeah, if you are going to use a T distribution, then we have to calculate the degree of freedom. Yeah, so we know what is the alpha value because we have already determined the significance level is 0.05 and we know n, yeah, from the example is 50. So 1 minus 0.05 it will be 0.95 and 50 minus 1 it will be 49. Okay, so what we are going to do now is we are going to place this formula into Microsoft Excel and determine what is the critical value here. Okay, so we have the data here, okay, that the CEO collected, yeah, a sample size of 50 businesses. So we are going to calculate the critical value. Yeah, so you remember the formula was T dot I and V. Okay, so we want to put in the probability which is 0.95 and the degree of freedom was 50 minus 1. It is 49. Yeah, we click enter. So the critical value is 1.6. So we have already find the critical value here. It is 1.68. So we have already labeled over here. So now what we want to do next is we want to find our T value. Okay, our T statistics. We want to see whether it falls in the rejection region or it falls, okay, under the non-rejection region in order for us to make a decision. Yeah. So what we do next is we need to calculate our T statistics. Yeah. So remember, this is the formula to calculate the T statistics. We only know the hypothesized mean and we only know the sample size. So we have yet to calculate the mean and the sample standard deviation. So let's calculate the mean. Yeah, so remember, whenever you want to insert a formula, you need to put an equal sign here. So the formula for mean is average. So average, you select your sample here, enter. So we've already got the sample mean. The hypothesized mean was 8 from the data. Okay, now we want to calculate the standard deviation. Yeah, so it's a sample standard deviation. Again, we want to insert the formula, equal sign. Okay, so it's the STDEV dot S. So we can already calculate the sample standard deviation. So it's 1.54. And we know what is the sample size. It was 50. So now you can see we have all this value already. Yeah, we're going to find the T statistics. So how do we find the T statistics? We insert a formula. So start with an open bracket. So we already have the mean minus the hypothesized mean, we close the bracket, divide, we have the, okay, we open up another bracket, we have the standard deviation, okay, of the sample, we divide by square root of the sample size, okay. So the square root is, you just put SQRT square root. So the sample size here is 50. You close this red bracket and you close the entire bracket here. Yeah. So when you click enter, you already get your T statistics value. Okay. So let's go back to our diagram where we have already inserted the critical value. So you can see over here, yeah, just now we have already calculated the critical value, which is 1.68. Yeah. And now we have calculated the test statistics. It's 0.37. Yeah. So this value 0.37, yeah, falls over here, which is under the non-rejection region. Yeah. So if the test statistics is greater than the critical value, we reject the null hypothesis. But in this case, we cannot reject the null hypothesis. Why? Because the test statistics is smaller than the critical value. Yeah, so we need to make a decision. It's in the non-rejection region. So there is insufficient evidence to conclude that the H1 is true. Yeah, so that's the decision that we have made. So once we are done with the critical value approach, we can also use the p-value approach. Yeah, so let's look into the p-value approach. Use p-value for t-test one tail right. Yeah, because we have to use the correct formula. So we know it's one tail, okay, and it's on the right hand side. Again, we have known this from the hypothesis. So this is the Excel formula that we use. 1 minus t dot dist bracket t. Yeah, the t here is the t value that we have calculated is 0.37. We have the degree of freedom n minus 1, which is 50 minus 1, 49. And we have to put the value true. So if we calculate the p-value and the p-value is less than the significance level that we have selected, yeah, so for this particular example, the significance level is 0.05. So what happens is that we reject HO. But if the p-value is greater than the level of significance that we have selected, we do not reject the HO. Yeah. Let's conduct the test using Microsoft Excel. So let's find the p-value, yeah, using Microsoft Excel. You put an equal sign here. 1 minus t d, okay, it's already here, t distribution. So what you get over here is, we need to know the x value. We have already calculated, which is the t value here, yeah, 0.37. Then what it wants is that it wants the degree of freedom. So the degree of freedom is 50 minus 1, which is 49. And, okay, it wants the, so we will select true. Yeah, we will select true here. We click enter. So you can see the p-value is 0.36. Now, let's see what this 0.36 indicates. So we have already calculated the p-value, yeah, using Microsoft Excel, and it was 0.36. So the p-value is greater than the significant levels that we have selected. Remember, the significance level that we selected for this test was 0.05. Yeah. So if the p-value, if you see into the table here, if the p-value is greater than the level of significance that we have selected, we do not reject the HO. Yeah. So we can say there is insufficient evidence to conclude that H1 is true. Yeah. So you can see both using the critical value approach and p-value approach, we do not reject the HO. Okay, let me share with you another example. Yeah, the earlier example, we looked into one-tailed test. And in this example, I'm going to show you a two-tailed test. Let's look into the example. A 3 Michelin star restaurant in Kuala Lumpur on Sunday claims that the mean meal waiting time is 15 minutes. A random sample of 40 customers was taken to test. Is the mean meal waiting time different from 15 minutes? Okay, so we want to see whether it's different. So the H null, okay, the hypothesized mean equals to 15 minutes. Yeah, because we want to see whether it's different from 15 minutes, so it can be either greater or lesser. Yeah, so the alternative hypothesis is the hypothesized mean not equal to 15 minutes. Yeah. So same thing here again. Yeah, we will be using a T statistics. Yeah, because the population standard deviation is not known. Yeah, sigma unknown. So you can see we already know what is the mu here. It's 15, and we know the sample is 40, and we have to find the mean and sample standard deviation. Yeah. So again, yeah, we can use the critical value or the p-value approach. So for critical value approach, from the hypothesis, we already know it's two-tailed. Yeah, so you can see we have the rejection region both on the upper and the lower here. Yeah, so we have selected a significant level equal to 0.05. So we need to find the critical values here. Yeah, so we can use this Excel formula t.inv.2t, yeah, because it's two-tailed. So we already know what is the significant levels and the degree of freedom. So we have 0.05. The degree of freedom is 40 minus 1. So let's put this in the Excel formula, yeah, and find the critical value. So I have this hypothetical data, yeah, which is for the meal waiting time. So let's find the critical value here, yeah. So you put an equal sign, t dot inv. Okay, so you see it's t dot inv two-tailed. So you click on this. We know what is the probability, which is 0.05, and the degree of freedom just now was 39. Yeah. So you press enter, and we can see the critical value is 2.02. So this is already for two-tailed. So the critical value that we have computed, yeah, in the Excel just now, we're going to place it into this diagram. So it's two-tailed. So therefore, it will be on the both sides, the upper and the lower. So the upper will be 2.02, and the lower now will be negative 2.02. Yeah. So once we have already got the critical values, so we need to know whether we are going to reject or we do not reject our null hypothesis. Therefore, now we need to conduct the test statistics. I mentioned we're going to use the T statistics. Yeah, it's sigma unknown. We know what is the hypothesized mean 15. We know the sample size. Yeah, but we are yet to know, yeah, the standard deviation of the sample and the mean. So let's calculate. So let's calculate the T statistics. So first we have to find the mean. You put an equal sign, average. So you select the waiting time. So we already got the mean. The hypothesized mean was given is 15 minutes. We need to calculate the sample standard deviation. So STDEVS. Yeah. Again, select the data. We have already got the sample standard deviation. We know the sample size was 40. Yeah. So now we have already received all the values here, and we can calculate the T statistics. Equal sign. So we open bracket. We have the mean minus the hypothesized mean, close bracket, divide by, we open bracket. We have the sample standard deviation. Yeah, we divide with the square root of the sample size. So we put in the square root, SQRT. Yeah, and we have 40. We close the bracket and we close the entire bracket. Yeah, and we click enter. Yeah, it is 4.67. So we can see the T statistics, which is 4.67. Yeah, it falls into the rejection region. Therefore, yeah, looking into the value, okay, falling into the rejection region, we can make our conclusion that we reject the null hypothesis. And we conclude there is sufficient evidence to conclude that H1 is true. So for p-value, yeah, for t-test two-tailed, we will use the Excel formula where t.dist.two-tailed t, degree of freedom n minus 1, and we will use this formula if the t is greater than 0. So we know that the t is greater than 0. It was almost 4 just now. Yeah. So I plug in into the formulas. So I know that the t is 4.61 and the degree of freedom is 40 minus 1. It's 39. Yeah. So let's calculate, yeah, the p-value from the Excel. So let's calculate the p-value, equal sign t dot kt distribution two-tailed. So what they require here for us is, we need to put the value of the t-stats, which is 4.67, and we need the degree of freedom, which is 39. We click enter. So you can see the p-value here, is equal to 0.00. So what does this value says? Let's go back. So if you see, the p-value that we got was 0.00. So the p-value is less than the significance level, and the significant level that we selected was 0.05. Therefore, if you see, if the table p-value, if it's less than the significant level, we reject HO. So therefore, the decision that we have made, we reject HO. Why? Because there is sufficient evidence to conclude that H1 is true. So it means that the waiting time is different, as compared to the hypothesized mean, which was 15 minutes.